second.
Okay guys, so next topic natin is all about the equilibrium of parallel forces. The conditions for equilibrium of parallel force system are determined from the conditions necessary to create a zero resultant. So we all know before from the topic of resultant of parallel forces that our working equation is summation of forces will be equals to the resultant and summation of moment will be equals to the resultant times the perpendicular distance. So the independent equation of equilibrium for parallel forces are the following. So again, kagaya nga na sinasabi ko lagi, kapag equilibrium equation, ang R is mapapalitan lang ng 0. Since we assume that the resultant is equals to 0. Or it will create a problem for equilibrium. Okay guys, so ito naman, parallel forces lang. So try natin sa example. Okay guys, so let's compute this problem. Pero bago natin siya isolve, I understand na yung ibang video, yung mga naunang video for this chapter, ay nagkaroon ng some audio problem. So ganito na lang yung gagawin natin. Doon sa last video na i-upload ko, magsosolve ako ng mga random problems para makompensate yung mga naunang problem na medyo may problema sa audio. But sabi naman ng ibang estudyante na susundan naman, so anuhin nyo na lang din, panoorin nyo and sundan nyo na lang yung problem habang sinosolve ko siya sa video. So, bawi tayo. Magdadagdag ako ng video for this chapter. Okay? So, basahin natin agad yung problems. So, a beam simply supported at end carries a concentrated load of 300 pound. So, meron siyang 300 pound 2 feet away from the first support. And a uniformly distributed load weighing 100 pound per linear foot. So, ito siya. So normally, ganito yung kanyang pinakita niya na ganito siya. Pero normally guys, ang uniform load is ganito yung itsura. Meron siyang puro pababang So ang ibig sabihin niyan guys, in every foot, meron kang 100 pound. So since ang may jeep, so since ang napapatungan niya is 6 feet, so itong 100 pound per feet na ito, pwede nating palitan ng isang concentrated load, kagaya nito, yung 300 pound. So ang gawin mo lang, so yung 100 i-multiply mo ng total span. So ito pwede nating palitan as a concentrated load, which is acting dito sa gitna ng 6. Or this is, ilan na to? So 100 times 6. So kung mapapansin nyo, pound feet yung unit ng 100, and then i-multiply mo ng 6 feet, so matitira na lang sa'yo is pound. Okay, maa-cancel na yung feet. So, 600 pound. So, that is at a distance of 3 feet away from this support. Okay? Or kung gusto nyo, gamitin nyo na lang tong 100 pound per feet. So, I think you will still arrive at the same equation if you're going to solve it. So, guys, it is a simply supported beam. Ibig sabihin yan, pinakita naman dito that meron siyang reaction dito sa magkabilang dulo ng beam. Okay? So, the goal here is to determine the beam reactions. Okay. So, ang mga working equation na gagamitin natin dito, so let's just say that this is point A and this is your point B. So, ang gagawin natin, either ang gagamitin natin is parehong summation ng moment. So, pwede tayong mag-moment at A and mag-summation ka ng moment at B. Or, ang gawin natin isa, pakita ko na lang na pareho dapat ang lalabas. Pwede mag-moment tayo either kay A or B and then yung isang equation is yung summation of forces y. So moment A or moment B and summation of forces y. So dapat we will still arrive at the same answer using these two options. So unahin ko yung option A ha. Itong option 1. So yung option 1 is both magte-take sign ng summation of moment. So ang gawin natin moment at point A. So when we take summation of moment at A equals to 0, so ito, dito mo papaikutin yung mga forces na yan. So ano yung mga forces na i-consider? So again, itong 300 pound, itong 600 pound, and yung reaction B. Okay, doon sa point Bing yun. Okay? So, unahin natin yung 300 pound. Ano mapoproduce na moment ng 300 pound? So, di ba 300 multiply by the perpendicular distance, ayan, yung distance na yan, which is 2 feet. And then, yung 600 pound. So, 600 pound, so plus 600 multiply by the perpendicular distance na, so ano yung distance niya? Away from point A, doon sa point na pinagmomomenta natin. So, ito siya, di ba? Ayan. So, ano yung distance na yan? So, knowing that the total span is 10 feet, and yung 600, the distance niya away from support B is 3 feet, so that will be 10 minus 3, or that will be 7 feet. So, 600 times 7. And then, yung R2, where yung R2 is anong moment ang maproproduce? So, counterclockwise, therefore, magiging minus R2 multiply by 10. Okay? Multiply by 10. So, ang gawin ko na lang, i-transpose ko siya doon sa kabilang side ng equation. So, magiging positive siya or magiging ganito yung equation. Okay? So, equals to R2 times 10. Therefore, R2 will have a value of, so gamitan lang natin ng calcu. Yan, wala pala yung calcu natin. So, ito. So, 300 times 2 plus 600 times 7 divided by 10. So, the answer is 480 pound. Okay, next. After taking summation ng moment at A, mag-moment naman tayo sa B para mahanap natin yung reaction 1. So, ganun lang ulit. Take summation ng moment at point B equals to 0. So, ngayon, dito naman tayo sa point na to magpapaikot ng mga force. So, unahin natin yung R1. Anong moment ang na-produce ni R1? Clockwise, di ba? So, positive. So, 10, the perpendicular distance na 10, times R1, and then yung 300 pound. Okay? So, 300 pound will produce a counterclockwise moment. Okay? So, minus 300 multiply by the distance of, so, gawin mo, 10 minus 2, so that will be 8. Nakita yung 10 minus 2? So, ito lang yung distance na yun, eh. Ayan, yung kinukuha natin. Perpendicular distance. That is 8. And then yung 600, so minus din, since counterclockwise moment din yung maproproduce niya, itong force na to. So, counterclockwise yung ikot niya, papunta kay B. So, that will be 600, so minus 600 times the distance of 3 is equals to 0. Okay, so transpose mo lang sa kabila. So, that will be 300 times 8. So, 300, transpose ko na lang sa kabila, times 8, plus 600 times 3, and then divided by 10. Okay, so the answer is 420 pound. Okay, so this time, gamitan natin ang option 2. So, by using option 2, so, ang gawin natin, moment A or moment at B. So, since nakuha na naman natin yung value ng isa, so, anong gusto nyo? So, gamitin natin si R2. So, di ba nakuha na natin si R2? 480 pound. Ngayon, ang gagawin natin, magsasummation tayo ng forces Y. Kasi ito, ginamit ko na lang dito, moment at A. Since nakuha na naman natin earlier, so, pili ka na lang kung alin ang gusto mong gawing reference. At kung aling value yung i-check natin. So, napili natin is moment A to get the value of R2, which is 480 pound. So, ngayon, ang gawin natin, mag-take tayo ng summation ng forces Y. So, papakita natin that yung R1 is, mapapalabas natin yung 420 pound using summation of forces Y. Okay? So, the equation will be R1 plus R2, and then minus, since pababa yan, 300, and then minus 600 pounds, since pababa yan 600, equals to 0. Therefore, R1 will be equals lang sa, so transpose mo sa kabila, so 300, so plus 300, so transpose mo rin yung negative 600, so plus 600, and then yung R2, so since transpose mo doon sa kabilang side, so positive 480, so magiging minus 480. So, equals lang sa 420. Ayan. So, guys, nasa sa inyo kung alin yung gusto nyong gamitin. Ano? So, ano lang naman yan? Combination. Pwede kang mag-moment A or moment B, or pwedeng moment A ka or moment B, and then yung isang equation, mag-summation ka ng forces Y. Hindi na natin ginamit yung summation ng forces X, ha? Kasi kung mapapansin nyo, wala naman tayong horizontal forces na hinahanap. Okay? Okay, so let's proceed with the next topic. Okay, guys. So, last topic natin for equilibrium is the 3.7 or the equilibrium of non-concurrent force system. So, non-concurrent na siya. So, the resultant of a non-concurrent force system could be determined from the components or summation of forces X, forces Y, and summation ng moment. And Therefore, the resultant will equal to 0, hence equilibrium will exist only when the following. So again guys, ito is combination lang ng mga equation na to and depende sa point na available or kung saang point mas madaling makakakuha ng value or unknowns. So combination lang, iikot lang dito sa tatlong equation na to. So dito naman, nagpakita siya ng moment A, moment B. Moment A, moment B, moment C. Ito, hindi lang napakita yung diagram, but ito yung equations na ginamit dun sa discussion sa inyong module. So, pakibasa na lang. Pero ito naman, application lang ng tatlong equation na to. So, diskarte nyo kung paano kayo mas madaling makakahanap ng mga unknowns. Okay? So, para mas maunawaan, try natin isolve yung kamukha ng problem na sinolve natin dun sa module 2. Yung last problem dun. Okay. Okay guys, so as shown here in the figure, we have a roof truss and supported on rollers at point A. So meron kang roller dito and hinge at point B. The wind loads are perpendicular to the inclined members. So ayan, perpendicular daw siya dito. So we need to determine the components of the reaction at A and B. Okay, so first thing that we need to do is to determine the reactions. So guys, since lahat ng forces mo has a downward force component, ito di ba downward, ito yung component niya, yung y component is downward. So yung mga reaction natin, kaya nga reaction and support, so yung direction nila is dapat ma-counteract niya yung mga forces na to. So dito, di ba roller yan, ilan nga ang reaction sa roller? Di ba isa? And it is always perpendicular dun sa surface na pinagpapatungan niya. So ito, pataas. So meron ka ditong pataas na force. So tawagin na lang natin siya as your RA. And dito, sa hinge, di ba dalawa ang kanyang reaction? Meron kang vertical. Pangalanan natin siya as RBY. And meron siyang horizontal. Pero pa saan ba yung horizontal reaction niya? Okay, so analyze mo muna yung buong figure. So di ba ito inclined forces? So ibig sabihin, meron siya ring X component. So pa saan yung kanyang X component? Di ba papunta sa kanan? Therefore, to counteract that rightward force, dapat ito papunta sa kaliwa. So that will be your RB. X. Okay, so we need to solve for the values of these three. So by using the equilibrium equation, so ilan yung ating equilibrium equation? So di ba meron tayong summation of forces X, we have summation of forces Y, and we have summation ng moment. So pipili na lang tayo sa mga point na yan kung saan natin tayo magsa-summation ng moment. So either naman sa dalawa, A or B, pwede tayo mag-moment. Okay? Okay, so ang gawin natin, mag-apply tayo nung natutunan natin from the previous topic, yung pagkuha ng resultant. So ang gagawin ko, since ito naman uniform yung loading niya, when I say uniform, meron ka dito na 100 pound, and then sa gitna, 200 pound. And as you can see here, yung distances naman nila, iisa, 20, 20, 20, 20. So ito, malamang-lamang, equidistant siya. So ang gagawin ko, I will convert this into a single force. Itong itong tatlong force na to, itong 100, 200, 100, i-convert natin siya into a single force. So since balance naman yan, ang mangyayari dyan, it will act here at the center. Ayan. So, convert natin siya into a single force na, so, anong value niya? So, di ba siya ay 100 plus 200 plus 100 or that is equals to 400 pound. And next, since walang angle na binigay dyan, hindi kasi natin alam yung angle na to. With respect to sa vertical, kung ano yung angle of inclination niya dito. So, gamitin na lang natin guys is yung slope. Okay? So, para masanay din tayo sa paggamit ng slope. Okay, so, saan ba natin makukuha yung slope? So, tama. Given naman yung mga dimension ng ion truss, or dito, anong magiging slope niya? Di ba ito 3? And then ito. Pakita na lang natin. Yan. Naka-form kasi siya ng triangle. Okay? Kung saan ito, 3, 30, itong baba, 40. So that is divisible by 10. Or we could say that itong slope niya will be equal saan? Di ba yung vertical is 3? Yung baba is 4. And yung kanyang hypotenuse, so that is square root of 3 squared plus 4 squared, or that will be equals to 5. So, ganun lang yun din yun dito. So, mangyayari dyan, vertical, ayan. So, this is your 3, this is your 4, and this is your 5. Okay? So, ito yung theta, ha? Baka magtataka kung ba't nagkabaligtad yan, ha? Kasi, di ba ito yung magiging theta mo? Kung titingnan mo siya dito, ito yung magiging theta. Okay? So, kaya nangyari, ito yung 3 niya, ito yung 4, ito yung 5. Okay? So, kung meron confusion dito, pa-review na lang ako ng inyong trigo. But, pakita na nga natin. Ayan. So, di ba ito yung theta? Ito yung inclined surface, di ba? Kaya sabi nga, perpendicular siya dito. Ayan. Na-form siya ng 90 degrees. Ngayon, kung drawing ako dito ng vertical line, ayan. Hindi siya vertical. Tabingi eh. Pag nag-drawing ako dyan ng straight line, so di ba ito 90. Tama? Ito magiging 90, and then itong angle na to will be 90 minus theta. Kasi before, di ba ito is perpendicular din dun sa anong yan. So kaya nangyari, ito will be equals to theta din. And ito, kabilang side, ito theta lang din. Okay? So yun lang yung ano yan, explanation din. And ito naman property lang ng mga angle-angle. So let's get back to this problem. Okay, so ano bang gusto nyo gawin natin dito? So either of these two naman eh. Pwede. Kung moment ka sa A, mahanap mo yung RBY. RBX, as you can see here, magiging concurrent siya doon sa point A. So wala siyang perpendicular distance. Zero yung magiging value nito kapag nag-moment tayo. Pero hindi ibig sabihin zero yung value niya. Kasi kung mapapansin mo, mahanap natin yung value ng RBX when we take summation of forces horizontal. By considering this, the horizontal component of this force. Sige, unahin na natin yung RBX. So para makuha si RBX, ang gagamitin mong equation is yung summation of forces X. Ayan. Equals to 0. Okay. So ang kapartner lang nitong RBX is yung horizontal component nito. Or that is 400. Paano makuha yung horizontal? O yung X component, multiply by 3 over 5. So di ba pakanan yung kanyang X component, so positive, and then yung RBX, so since papunta sa kaliwa, so minus RBX is equals to 0. Therefore, RBX is equivalent to 400 times 3 divided by 5. 400 times 3 divided by 5. So that is 240. Okay, so we're done. May nakuha na tayong isa. This is 240. Next. Ang sunod natin pwedeng gawin, saan kaya tayo pwede mag-moment? Sige, dito na lang, para at least, ito yun eh. Maalalaman na natin yung perpendicular distance mo dito. Ano? So, paano makukuha yung distance na yan? Okay, so we all know that this is 20. And ito, since 20-20 naman siya, ito, kung 30 to, ito magiging 15. By similar triangle lang ha. Ni-ratio and proportion ko lang. And then, para makuha yung distance na yan, so just take the hypotenuse, or that is square root of 20 squared plus 15 squared. Or the length of this distance is 25, yung perpendicular distance niya. Okay, ang gawin natin, summation tayo ng moment at point A. Para at least ma-take advantage natin yung perpendicular distance. No? Kasi ito, mag-perform siya ng 90 degrees. Okay, so moment at A, considering clockwise direction as positive, equals to 0. So unahin muna natin to. So 400, positive yan na, makakapag-produce siya ng clockwise moment pag ganun yung ikot niya. So 400 times 25. And then next, ano pa yung mga forces? Ito, itong 200 na to. So plus 200. Guys, huwag kang kalimutan i-consider lahat ng force ha. Baka may makalimutan kayo. Tingnan nyo mabuti. So times 20. Plus yung 200 na isa, yun nasa gitna. So plus 200 multiply by the distance of, so 20 plus 20, so 40. And then plus yung 200 ulit. Actually, pwede rin pala natin itong ginawang kinonvert natin to a single force, no? Concentrated naman dito sa pinakagitna. So, yan ay equal sa 600. Anyway, since na-solve na naman natin, huwag na natin gawin. Isa-isahin na lang natin. Ano? So, plus 200 times, so 2046 times 60. And then, meron pa bang force? So, again, yung RBX mo naman will be concurrent. So, wala siyang perpendicular distance. So, isi-zero na lang natin yung value niya. And then, RBY. So, since counterclockwise yan, so minus RBY times the distance of, so 20, 20, 20, 80. So equals to 0. So RBY will be equals to, so 400 times 25 plus 200 times 3. So plus 200 times 20 plus 200 times 40 plus 200 times 60. And then divided by 80. So the answer for RBY is 425. Okay, so meron na tayong value nito, 425. And then for RA, so either mag-moment ka kay B para makuha mo si RA. But as you can see here, medyo complicated lang ng kaunti kasi kailangan mong hanapin yung x and y component niya, and then i-moment mo pa siya individually. Or ang pwede mong gawin, kagaya ng ginawa natin sa previous problem, mag-summation na lang tayo ng forces y, kasi pwede pa natin gamitin to. Ano? Kasi, ang mangyayari lang, ayun lang, sa summation lang tayo ng forces y, kunin natin yung y component itong 400, then i-add natin itong mga to, and then i-subtract natin siya sa RBY para makuha. Anyway, pakita na lang natin. So, take summation ng forces y equals to 0, assuming upward direction as positive. So, ano ba yung mga pataas? So, we have RA, unahin muna natin yung mga pataas. And then plus RBY, kung saan yung RBY has a value of 425. 425, and then, since pababa to, so minus 200. So, pag sumasamayan na lang natin, so 200 times 3, okay? Kasi tatlo. And then, minus yung y component itong 400. So, minus 400 times 4 over 5. And then, equals to 0. Okay guys, so input lang natin sa CalQ. So RA, so itatranspose natin siya sa kabila. So magiging 400, ito muna ha. So yung 425, dali natin sa kabila. So negative 425, and then minus, so plus 200 times 3. And then yung 400, so plus 400 times 4 divided by 5. So 495. The answer is 495 pounds. Okay, so tama naman yung assume natin kanina. Okay guys, so these are the answer for the unknown in the problem. So guys, kung gusto niyo siyang pagsamahin tong RBX and RBY, so by Pythagorean na lang. No? So RB is equals to square root of RBX squared plus RBY squared. And then kung gusto mo makuha yung theta niya, yung angle of inclination niya, si RB, gusto mo makuha yung tetang yan, di arctangent po lang. Ano? Okay guys, so I think this is part 5 of our video. So yung last video, so that will be composed of random problems for this chapter. So ayun nga, pambawi natin para do sa nasirang audio do sa mga unang part ng ating discussion. Okay, so thank you, and subaybayan nyo na lang yung sunod na video.